The Cournot Duopoly model is a fundamental concept in game theory, specifically in the study of oligopolies, markets dominated by a few firms. It was developed by French mathematician and economist Antoine-Augustin Cournot in 1838. It provides a framework for understanding how firms compete when they choose their output quantities simultaneously. Let's break down the Cournot Duopoly model from a game theory perspective. 1. Game theory fundamentals in Cournot Duopoly. In the context of game theory, the Cournot Duopoly is modeled as a simultaneous move game with imperfect information. Each firm makes its decision without knowing the other's exact choice at that moment. Players, the two firms, let's call them Firm 1 and Firm 2, in the duopoly. Actions, strategies. Each firm's strategy is to choose a quantity of output, Q_1 for Firm 1, Q_2 for Firm 2, to produce. These quantities are chosen simultaneously. Payoffs. The payoff for each firm is its profit, which depends on its own output and the output of the other firm, as total output determines market price. Information. Each firm knows the market demand curve, its own cost structure, and the cost structure of its rival. Critically, each firm assumes its rival's output decision is fixed when making its own decision. This is often referred to as a no conjecture assumption or a Cournot conjecture. 2. The core assumption, strategic interdependence in quantity. The central assumption of the Cournot model is that each firm decides its output level assuming that the output of its competitor will remain constant. This doesn't mean they ignore each other. Rather, they incorporate this assumption into their profit maximization process. Intuition. Imagine two well drillers in a town, both selling water. Each driller knows that if they pump more water, the price of water will fall for everyone, including themselves and their competitor. However, when driller A decides how much to pump, they assume driller B will continue pumping their current amount, and then adjust their own pumping to maximize their profit based on that assumption. Driller B does the same thing, simultaneously. 3. Reaction functions, best response functions. To find the equilibrium, we use the concept of reaction functions, also known as best response functions. A firm's reaction function shows the profit maximizing quantity it will produce for every possible quantity chosen by its competitor. How it's derived. 1. Each firm sets up its profit maximization problem. Profit, pi, equals total revenue, TR, total cost, TC. 2. Total revenue is price, P, asterisk quantity, Q. The price depends on the total market quantity, Q equals Q_1 plus Q_2. So, P equals F, Q_1 plus Q_2. 3. Each firm then takes the derivative of its profit function with respect to its own quantity, setting it to 0 to find the profit maximizing output. 4. Crucially, when firm 1 differentiates its profit function with respect to Q_1, it treats Q_2 as a constant. This yields firm 1's reaction function, Q_1 equals R_1, Q_2. 5. Similarly, firm 2's reaction function is derived by treating Q_1 as a constant, Q_2 equals R_2, Q_1. Intuition. The reaction function for driller A says, if driller B pumps X gallons, I'll pump Y gallons to make the most profit. And vice versa for driller B. 4. Nash equilibrium. The solution to the Cournot Duopoly model is a Nash equilibrium. A Nash equilibrium is a state where no player, firm, can improve its payoff, profit, by unilaterally changing its strategy, given the strategies of the other players. How it's found. The Nash equilibrium in a Cournot model is the point where the two reaction functions intersect. At this point, both firms are simultaneously on their best response curve, meaning neither has an incentive to change its output. Intuition. It's the point where driller A's optimal pumping quantity, assuming B's quantity, matches driller B's optimal pumping quantity, assuming A's quantity. They found a stable, sweet spot, where neither wants to move. 5. Outcomes of the Cournot model. Output and price. The total output in a Cournot duopoly is greater than what a monopolist would produce, because there's competition, but less than what would be produced under perfect competition, because firms still have market power. Consequently, the market price is lower than the monopoly price but higher than the perfectly competitive price, which would equal marginal cost. Profits. Both firms earn positive economic profits, though these profits are lower than what a single monopolist would earn. Deadweight loss. There is still a deadweight loss, inefficiency, compared to perfect competition, but it's smaller than that under a monopoly. As the number of firms increases, a significant finding of the Cournot model is that as the number of firms in the oligopoly increases, the market outcome approaches that of perfect competition. If there are infinitely many firms, the price will equal marginal cost. 6. Criticisms and limitations. Despite its importance, the Cournot model faces some criticisms. Naive assumption. The assumption that each firm believes its rival's output will remain fixed is often criticized as being unrealistic, especially in a repeated game. Firms might learn and anticipate reactions. Simultaneous decision-making. In reality, firms might not make output decisions simultaneously. One firm might act as a leader, or decisions might be sequential, addressed by the Stackelberg model. Homogeneous products. The basic model assumes homogeneous products. If products are differentiated, the analysis becomes more complex, though extensions exist. Focus on quantity, not price. The model assumes firms compete on quantity. In many industries, firms primarily compete on price, addressed by the Bertrand model. Lack of collusion. The model assumes non-cooperative behavior. Firms might collude, form a cartel, to maximize joint profits, leading to a monopoly-like outcome. However, the Cournot equilibrium still serves as a baseline for understanding the incentives to deviate from collusion, like in a prisoner's dilemma. Cournot versus Bertrand versus Stackelberg. It's helpful to compare Cournot with other duopoly models. Cournot, quantity competition, simultaneous. Firms choose quantities simultaneously, assuming the rival's quantity is fixed. Bertrand, price competition, simultaneous. Firms choose prices simultaneously, assuming the rival's price is fixed. This often leads to a result where price equals marginal cost, similar to perfect competition, even with just two firms, known as the Bertrand paradox. Stackelberg, quantity competition, sequential. One firm, the leader, chooses its quantity first, and the other firm, the follower, observes this choice and then chooses its quantity. This gives the leader a first-mover advantage. Conclusion. The Cournot duopoly model is a cornerstone of game theory and industrial organization. It was one of the first models to systematically analyze strategic interaction between firms in an oligopoly. By focusing on quantity as the strategic variable and introducing the concept of reaction functions leading to a Nash equilibrium, it provided invaluable insights into market outcomes under imperfect competition, bridging the gap between pure monopoly and perfect competition. While its assumptions have been debated and refined, its foundational contribution to understanding strategic decision-making remains highly relevant.